Hi there guys. So what we're going to be doing today is having a little look at covalently bonded molecules, specifically the shapes of covalently bonded molecules. So over the last couple of weeks we've been looking at what covalent bonds are, which type of elements covalently bond. We have looked at drawing covalent bonded diagrams or dot and cross diagrams, and we've also looked at the diatomic elements as well. So today we're going to be focusing on the shapes of those molecules. What do they look like when they're out in space? So, what I wanted you to start with are the questions that are up on your screen just now. So, true or false starter questions based on the last couple of lessons. So, our first question was diatomic molecules are covalently bonded, true or false? Well, we know that that is indeed true. Diatomic molecules are covalently bonded. Question 2, Cl2, I2 and C2 are examples of diatomic molecules. Well, we know that Cl2 and I2 are examples of diatomic molecules, and we can check that by looking at our periodic table. So we know NO, F, Cl, Br and I, they are our magnificent 7. They are our diatomic molecules, including hydrogen up here as well in group 1. But C2 is not a diatomic. Carbon is not a diatomic molecule or element, therefore that is false. And question number 3, covalent bonds are held together by the mutual attraction of the positive nucleus for the negative electrons. That is the definition of covalent bonding, so that is true. So what we're going to look at today, as I've said, is the shapes of molecules. And by the end of the lesson today, I want you to be able to identify the shapes of different molecules by looking at the chemical formula and working out what shape should this molecule have. To do was look at wedge and hash bonds. So before we talk about the different types of shapes, we want to recognise that molecules are not flat objects, they are 3D. And we have to have a way of drawing those shapes 3D on paper. And how we do that is using wedge and hash bonds. So on the slide just now, we've got methane, which is a molecule of carbon with an atom of carbon with 4 hydrogen atoms bonded to the carbon. You'll see that we have a wedge bond here and a hash bond. The wedge bond actually represents the bond going in front of the plane of the board. So if I am the plane of the board, then this bond is going in front of me, and the hash bond is going behind me. So in front and behind, that's all that those mean. And if I take some pens here, I can show you what that actually looks like. So if my fist is the carbon atom, we'll have 1 hydrogen bonded up this way, 1 hydrogen bonded out this way, 1 hydrogen bonded in front of me, and 1 hydrogen bonded behind me to make this nice tetrahedral shape. Alright, that is what our wedge and our hash bonds mean. So the note that I wanted you to take in your jotter is up on the screen just now, and it explains the 4 different types of bonding molecule shapes, what they are called, what they look like, and also examples of different covalent molecules which adopt these shapes. So first of all, we've got the tetrahedral shape, and you can see I've got my pink atom in the middle of the tetrahedral molecule here, and all around the edges I've got these white balls or white atoms. So it's our central atom bonded to 4 other atoms, which means tetrahedral shapes make 4 bonds. So if you've got a molecule which makes 4 bonds, it has got a tetrahedral shape. Next we have trigonal pyramidal, and that just looks like a pyramid like you would see in Egypt. So we've got our central atom is my hand again, and my pens represent the 3 bonds. So this nice pyramid shape like this. So we've got our central pink atom in the middle, and our 3 other white atoms around the central pink atom. So things which have 3 bonds will be trigonal pyramidal. Our next shape is angular, and again, it's following a pattern here. Things which have 2 bonds adopt an angular shape with a central atom here in pink and 2 other atoms here in white. And last but not least, we've got linear. So we've went from 4 bonds, 3 bonds, 2 bonds, and linear are molecules which have only 1 bond in them. And we've got our central atom in pink and our other atom in white. So examples of what these actually might look like. for tetrahedral molecules would be a molecule, for example, methane, which is a carbon atom with 4 hydrogen surrounding it. That would adopt a tetrahedral shape. Ammonia is an example of a trigonal bipyramidal shape. Water is an example of an angular bonded molecule. And hydrogen chloride is an example of a linear bonded molecule. And we've got the chemical formula for those as well. So you can recognise how many bonds they have in the molecule. If we've got one central atom and 4 other atoms in the molecule, like methane, we know that that makes 4 bonds. We've got a central atom and 3 other atoms, that makes 3 bonds. Our central atom oxygen and 2 other atoms, that is 2 bonds. And our central atom chlorine and our other bond is hydrogen, that makes 1 bond. So what we're going to go to next is to look at how we apply this when we're doing questions. So the first task I wanted you guys to have a look at was looking at the chemical formulas of covalently bonded molecules and how you decide what shape that molecule is going to have. So you should have up on your screen just now A to F with 6 different molecules, and we're going to go through them one by one. If you haven't already done this task, you can pause the video, do them just now in your jotter or on a piece of paper, and then you can play the video and I'll go through them one by one for you. So let's start at A. So for A, we've got a silicon atom bonded to 4 hydrogen atoms. So this molecule is going to have 4 bonds in it because each of those hydrogens are going to be bonded to a silicon atom. And that is then going to adopt a tetrahedral shape. And we should be able to go one step further and we should be able to now draw that atom, that molecule and what it's going to look like. So we should have a silicon atom in the middle. We're going to have 2 normal looking bonds, silicon to hydrogen, and then we can put in our wedge bond to show that that one would be coming forward or facing in front of the plane, and we'll have our dash bond which would be away from the plane. So that is what a tetrahedral molecule of silicon bonded to 4 hydrogens would look like. For B, we've got a sulfur atom bonded to 2 hydrogens. So that molecule is going to have 2 bonds in it. So the shape of that molecule is going to be angular. We'll have our sulfur atom bonded to 2 hydrogens. For C, we've got a hydrogen bonded to bromine, so that is 1 bond. We'll have our hydrogen with 1 bond to bromine, and that is a linear shape. For D, we've got phosphorus bonded to 3 hydrogens, so that is going to be a 3 bond molecule. Phosphorus up the top bonded to a hydrogen. We'll also have a wedge bond here to show that this hydrogen is going away from the plane or in front of the plane, and this one is behind the plane. In fact, I can probably draw that a little bit better, I think. There we are. For E, we've got boron bonded to 3 chlorines. So that molecule is going to have 3 bonds, meaning it's going to have a trigonal, oh, I should have put that for D as well, trigonal pyramidal shape. And E would be the same, trigonal pyramidal. So we'll have our boron up the top, 1 normal chlorine bond, our wedge chlorine bond showing that that is going in front of the plane, and our hash chlorine bond to show that that chlorine is going away from the plane. And last but not least, we've got our selenium bonded to 2 hydrogens. So this is a 2 bond molecule. Each of the hydrogens would be bonded by a bond to selenium. It is going to be therefore angular. And it will be selenium, a bond to hydrogen, and a bond to hydrogen. So give yourself a tick if you got all those correct. Absolutely well done. If you challenged yourself and you managed to say what the name of the shape was and you managed to draw the actual shape, what the molecule looks like, that is excellent. Well done. Our final thing that we wanted to do in today's lesson is task 2, which is up on your screen just now. And I wanted you to be able to draw and name the shapes of the molecules A, B and C, except what I've done this time is not give you the chemical formula. So I want you to use that skill that you've learned many times this year of how to work out chemical formula. So if you've not done this yet, like the last task, pause the video, do the task, and then you can go through it with me. If you have done them, we can continue on. So for bromine iodide, we want to do the chemical formula first because we don't know how many atoms are actually in that molecule from the word formula. We need the chemical formula. So the symbol for bromine is Br, the symbol for iodine is I, the valency of bromine is 1 and the valency of iodine is 1 because they are both in group 7. And remember that our valencies go from group 1 to group 8, 1, 2, 3, 4, 3, 2, 1, 0. So bromine's got a valency of 1, iodine's got a valency of 1. We're going to swap them, divide them. They can only be divided by 1, so we're going to put them as 1 and 1. So our formula is going to be BRI. Now that BRI is going to have one bond in the molecule because there's only 2 atoms, so one bond. Things which have one bond have a linear shape. Therefore, this would be bromine iodide. Linear, bromine, bond, iodine. For B, we've got nitrogen hydride. So again, we're going to do SVSDF, nitrogen, hydrogen. Nitrogen is in group 5, so it's got a valency of 3. Hydrogen is in group 1, so it's got a valency of 1. Swap those over, 1 and 3. We can divide them again, both by 1, so we're going to have 1 and 3. So our formula is going to be NH3. This is ammonia. Ammonia will have 3 bonds in the molecule because we'll have nitrogen as our central atom, and we'll have nitrogen bonded to 1 hydrogen, a wedge bond for our second bond, and a hash bond for our third bond. So this again is going to be trigonopyramidal. That is the shape of that molecule, pyramidal. And last but not least, we've got carbon chloride. I'm going to do my SVSDF again. Carbon's symbol is C, chlorine symbol is Cl. Carbon is in group 4, so it's got a valency of 4. Chlorine is in group 7, so it's got a valency of 1. We can swap those over, 1 and 4. They both divide by 1, so we're going to put 1 and 4. And then our formula is going to be carbon Cl4. That molecule is going to have 4 bonds because we've got carbon with a bond to each of the chlorines, which is 4 bonds. So it's going to be a tetrahedral molecule, tetrahedral. And I'm going to draw it in this little space down the bottom to try and avoid my face. So carbon with a bond to a hydrogen, a second bond to a hydrogen, a wedge bond in front of the plane to a hydrogen, and a hash bond behind the plane to a hydrogen. So basically the trigonopyramidal shape and the tetrahedral shape are the same, except your tetrahedral shape has that extra little bond coming out of the top of its head. So that is us pretty much finished for today. If you have any questions about today's lesson, please just shoot me a little email. You should now be able to draw the different shapes of molecules based on the chemical formula of the molecule, and you should be able to name the 4 shapes of molecules. So good work today, and enjoy the rest of your day.